Hello everyone, I'm Dr. Tokuma Gitaun, and today I'm here to explain some selected topics from different Oromia regions, and this lesson preparation was organized and sponsored by Oromia Education Bureau, and among the topics selected from different areas, one is organic compounds. Okay, the second most important class of organic compounds is oxygen containing compounds of hydrocarbons. They are also named as oxygenated hydrocarbons. So these are 6 in numbers. Okay, the first one is alcohols. Alcohols can also be named as alkanols. So OL indicates the presence of OH functional group because the functional group of alcohols is OH, and it is named as hydroxyl group. And the general formula for alcohol is ROH. In this case, R can never be hydrogen atom. If R is hydrogen, it becomes H2O, and H2O is water. Water is not an alcohol. Therefore, R must be alkyl group or aryl group. So this is the general formula for alcohol. The second one is ethers. Ethers are also oxygen-containing compounds of hydrocarbons, and the ethers can be named as alkoxy-alkane. Alkoxy-alkane is the IUPAC name for ethers. Ethers can be named as alkoxy-alkane. I will tell you this one later. And the general formula for ether is ROR prime. Oxygen is bonded with 2 alkyl groups. These alkyl groups may be the same or may be different. So we can name these kind of organic compounds, oxygen containing compounds of hydrocarbons, as ethers or alkoxy-alkane. The third one is aldehydes. Aldehydes are also oxygen containing compounds of hydrocarbons. They are named as alkanals. Alkanal, AL, okay? This one indicates the presence of carbon to oxygen double bond directly bonded to hydrogen atom. And the general formula for aldehydes is RC double bond OH. This is carbon to oxygen double bond is carbonyl group. And the carbonyl group is the functional group for aldehydes or alkanals. And this can also be written as RCHO, okay? The fourth one is ketones. Ketones are also named as alkanones. Alkanon, O-N-E, okay? This one also indicates the presence of carbon to oxygen double bond directly bonded with alkyl groups or aryl groups. Therefore, they can be named as alkanones. The general formula for alkanones is R, C double bond O, R prime. R and R prime may be the same or they may be different. But in this case, R prime can never be hydrogen atom. R also can never be hydrogen atom. If R is hydrogen atom, it becomes the general formula for aldehydes. But aldehydes are completely different from alkanones or ketones. And the fifth one is carboxylic acids. Carboxylic acids. Carboxylic acids are also known as organic acids. So you can also call them as organic acids. And their IUPAC names can be named as alkanoic acids. Alkanoic acids. Okay. The general formula for this type of organic compounds is RC double bond O OH. This C double bond O OH is the functional group for carboxylic acids. And the name of this functional group is carboxyl group. Carboxylic group containing compounds are named as carboxylic acids or alkanoic acids, or they are also named as organic acids. And this is the general formula for carboxylic acid. You can also write as RCOOH or RCO2H because we have 2 atoms of oxygen in this molecule. Therefore, it can also be written as RCO2H. The sixth one is esters. Esters are also oxygen-containing compounds of hydrocarbons. And the general formula for ester is almost similar with that of carboxylic acid, but here we have R prime, okay, but here it is hydrogen. Therefore, R prime can never be hydrogen atom. But R may be hydrogen atom or alkyl group or aryl group, or you can also say phenyl group, okay. So this is the general formula for ester. You can also write as RCOO R prime or RCO2 R prime. Okay, esters can be named as alkyl alkanoates. Alkyl alkanoates are the IUPAC names for esters. All these are oxygen containing compounds of hydrocarbons. Okay, let me show you the definition as well as some classification of these type of organic compounds. Important organic compounds. They are oxygen containing compounds of hydrocarbons, okay. So we have oxygen atom in addition to carbon and hydrogen atoms, because hydrocarbons are organic compounds containing only carbon and hydrogen atoms. But in this case, additionally, we have oxygen atoms in their molecule. These are 6 in numbers. They are also known as oxygenated hydrocarbons, or you can also call them as derivatives of hydrocarbons. Include alcohols, ethers, aldehydes, ketones, carboxylic acid, and esters. They are 6 in numbers. I already told you about this one. So let us see one by one. Especially, I will focus on their names, IUPAC names. Other one, for example, common name, their preparation, not only this one. All hydrocarbons, including alkanes, alkenes, etc. You can also see the preparation, their physical property, their chemical property, as well as their uses from your textbook. So alcohols, they are also named as alkanols. The functional group for alcohol is OH, and this functional group can be named as hydroxyl group. These are some examples of alcohols. This one contains OH, therefore this is a functional group for this molecule. And I told you that functional group is a part of molecule that determines the physical and the chemical property of that molecule. Therefore, because of the presence of OH in this molecule, this organic compound is classified as alcohol. And this one is also alcohol. But the difference between these two organic compounds is that here we have only methyl group, but here we have ethyl group. This one contains 2 carbon atoms, but this one contains only 1 carbon atom. And the name of this compound is methanol. But this one is ethanol. And this one is 1-propanol. Why 1-propanol? Because your OH functional group is on carbon number 1. If your OH functional group is on carbon number 2, the IUPAC name for that compound is 2-propanol. Okay? So I'll tell you this one later. So these are some examples of alcohols: methanol, ethanol, 1-propanol, or you can also name as propane 1-ol. This one indicates the position of OH group in this molecule. OL indicates the presence of OH functional group. That is a functional group of alcohol. Therefore, these are examples of alcohols. The general formula for alcohol, ROH2. This is for monohydric alcohol, okay? So we can classify alcohols based on their OH functional groups as monohydric, dihydric, trihydric, polyhydric, okay? I'll tell you this one later. So ethanol is the only alcohol present in all alcoholic beverages. Okay, classification of alcohols. Alcohols can be classified as monohydric. These are alcohols containing only 1 OH group in their molecule. Therefore, these are named as monohydric. Mono means 1. So, if you have only 1 OH group in the molecule, that alcohol can be classified as monohydric alcohol. For example, look at this organic compound. Look at this alcohol. We have only 1 OH group, but we have 2 carbon atoms. So, the name of this alkyl group is ethyl. Okay, I told you this one before. Therefore, the name of this compound is ethanol. It has only 1 OH group in the molecule. Therefore, this is monohydric. Why monohydric? Because we have only 1 OH group in the molecule. In this organic compound, we have also only 1 OH group. Therefore, this is also monohydric alcohol. The name of this one is ethanol. I told you about this one. This one, 1-propanol or propane 1-ol is the IUPAC name for this compound. So monohydric alcohols can also be classified into primary alcohol, secondary alcohol, and tertiary alcohol based on carbenol carbon. What is carbenol carbon? Carbenol carbon is nothing but the carbon directly bonded to the OH group, to the functional group. For example, this carbon is carbenol carbon. Okay? This carbon is carbenol carbon. Why? Because it is directly bonded to the OH functional group. However, this one is not carbenol carbon because it is not directly bonded to this OH group. It is bonded with this carbon and it is bonded with the 3 hydrogen atoms shown in this molecule. In this organic compound, this carbon is carbenol carbon. The carbon directly bonded to the OH group. Therefore, based on this carbenol carbon, we can also classify monohydric alcohols as primary alcohol. Primary alcohol, when carbenol carbon is bonded with only one alkyl group, such type of alcohols can be named as primary alcohols. So the general structure for primary alcohol is this one. This is carbenol carbon because it is directly bonded to the OH group. And this carbon is primary carbon. Therefore, an alcohol in which OH group is bonded to the primary carbon is simply known as primary alcohol. This carbon is only bonded with one alkyl group. Therefore, this carbon is primary carbon. It has 2 hydrogen atoms, okay? All the time remember this one. So, this is the general structure for primary alcohol. The carbon is primary carbon and the OH is directly bonded to that carbon. Because of that reason, we can classify this type of monohydric alcohol. Why monohydric? Because we have only one OH group in the molecule. Therefore, this is primary alcohol. Look at this carbon. The carbon directly bonded to the OH group, only bonded with one carbon atom. Others are hydrogen atoms. Therefore, this is one example for primary alcohol. Ethyl alcohol is the common name for this alcohol, but its IUPAC name is ethanol. The IUPAC name for this alcohol is 1-propanol, and its common name is N-propyl alcohol. This also primary alcohol, because the carbon directly bonded to the OH group, that carbon is carbenol carbon. I told you about that. Is bonded only with one carbon atom. Others are hydrogen atoms. Therefore, you can easily identify whether a molecule is primary alcohol or secondary alcohol by looking at the carbenol carbon. The carbon directly bonded to the OH functional group. So this is ethanol and this one is 1-propanol or N-propyl alcohol is a common name for this alcohol, but ethyl alcohol is the common name for this alcohol. Secondary alcohol. In this case, you can easily identify whether the molecule is or alcohol is secondary alcohol or primary alcohol or tertiary alcohol only by looking at the carbenol carbon. If, for example, the carbenol carbon bonded to 2 the same or different alkyl groups, and if that carbon directly bonded to the OH group, such type of alcohols are named as secondary alcohols. Primary alcohol, I told you about that. Now I'm talking about secondary alcohols. Okay, so in this case, the carbon directly bonded to the OH group is bonded with 2 other alkyl groups. Okay, 2 carbon atoms. Therefore, this carbon is secondary carbon. All the time remember this one. Primary carbon, secondary carbon, tertiary carbon. And the hydrogen atoms in primary carbon are known as primary hydrogen atoms. And the hydrogen atoms on the secondary carbon are named as secondary hydrogen atoms. And the hydrogen atoms on tertiary carbon are named as tertiary hydrogen atoms. But this carbon is secondary carbon. Why? It is directly bonded with 2 alkyl groups. And this carbon is also named as carbenol carbon. Why? Because it is directly bonded to the OH functional group. Therefore, this is the general structure for secondary alcohol. So try to look at the carbenol carbon to identify whether the alcohol is primary, secondary, or tertiary. Look at this organic compound, this alcohol. This carbon is carbenol carbon. The carbon directly bonded to the OH group. The same carbon is bonded with this methyl group and as well as this methyl group. So it is bonded with 2 carbon atoms. Because of this reason, this alcohol is secondary alcohol. It is not primary alcohol, secondary alcohol. OH is directly bonded to the secondary carbon atom. Therefore, it is secondary alcohol. Look at this organic compound. This carbon is carbonyl carbon. The carbon directly bonded to the OH group is also bonded to this carbon atom and this carbon atom. Two carbon atoms. Therefore, this carbon atom is secondary carbon. So, if OH is directly bonded to the secondary carbon, that alcohol is classified as secondary alcohol. What's the name of this organic compound? 2-propanol. Okay, this is the longest continuous chain. Your OH is on second position. If you number from left to right, it is on second position. From right to left, it is also on the second position. Therefore, the name of this alcohol is 2-propanol. 2-propanol is the IUPAC name for this alcohol. Its common name is isopropyl alcohol because this part is isopropyl. It is an alkyl group. I already told you about alkyl group. So you can also check from your textbook. You can also read alkyl groups from different materials. So it is really very easy to understand alkyl groups. So this is 2-propanol. What's the name of this one? When you start numbering from left to right, OH is on the second position. But when you number from right to left, it is on third position. All the time, you have to start numbering from the end, closer to the carbon directly bonded to the OH functional group. Therefore, the correct numbering system is from left to right. And the IUPAC name for this compound is 2-butane. An alkane that contains 4 carbon atoms is butane. In the case of alcohol, when you write the IUPAC name for alcohols, E of an alkane can be replaced by OL because OL indicates the presence of OH functional group. Because of this one, the IUPAC name for this compound is 2-butanol. 2-butanol is the IUPAC name for this compound. So try to identify this type of organic compounds from other. So this is the second classification. The third one is tertiary alcohol. This is also really very simple. If carbonyl carbon is bonded to 3 different carbon atoms, therefore this type of alcohols can be classified as tertiary alcohol, contain OH group attached to a tertiary carbon atom. This carbon is tertiary carbon atom because it is bonded with 3 different carbon atoms, different alkyl groups. Okay, so this organic compound, this alcohol is tertiary alcohol. The general structure for tertiary alcohol is this one. Okay, let me show you one example. For example, this is best example for tertiary alcohol. Why tertiary? Because carbonyl carbon, the carbon directly bonded to the OH group, is also bonded to 3 other carbon atoms. Okay, therefore this carbon is tertiary carbon. Due to this, okay, this organic compound can be classified as tertiary alcohol. And what's the name of this alcohol? Okay, so the longest continuous chain contains only 3 carbon atoms. Okay, so this is the longest continuous chain. And on the second carbon atom, we have OH group. On the same carbon, there is also another substituent. That is methyl group. Okay, side chain. That side chain is methyl. Okay, therefore, because of this one, when you number from left to right, OH is on second position. From right to left, it is on second position. So you can use either of the two. When you start from left to right, this is on second position, this is also on second position. So 2-methyl, 2-propanol is the IUPAC name for this compound. 2-methyl, okay? Then your OH is on second carbon, 2. Then an alkane that contains 3 carbon atoms is propane. E of an alkane must be replaced by OL to name the IUPAC names for alcohols. Because of this reason, the IUPAC name for this compound is 2-methyl 2-propanol. Okay, so this is an example for tertiary alcohol. Okay, let me ask you one question. CH3, okay, sorry, CH3, CH2, then CH3, CH3, CH2, OH. Is this alcohol primary alcohol or secondary alcohol or tertiary alcohol? So look at this carbon. The carbon directly bonded to the OH functional group. So this carbon is bonded only with this carbon atom. Therefore, this is primary alcohol. Okay, you can easily identify whether it is primary or secondary by looking at the carbonyl carbon. The carbon directly bonded to the OH groups. Another classification of alcohol based on OH group is dihydric alcohol. This one contains 2 OH groups. They are also named as glycols and the diols. Okay, this is best example for dihydric alcohol. We have 2 OH groups in the molecule, therefore it is dihydric. Di means 2.